Hey, it's Mr. Estrada here, and our learning target is I can multiply and divide rationals that require factoring. So, before you watch this video, you need to make sure that you have watched the review of factoring video and simplifying rationals part 1 and part 2. If you have not watched those videos, you're going to have a very hard time keeping up with this video. All right, so if you haven't watched those videos, you should stop this now and you should go back and watch those videos that I just named. Review of factoring, simplifying rationals 1 and 2. All right, so let's get started. It says warm up, perform the indicated operation. So here we're multiplying fractions. So as you know, when you multiply fractions, you multiply across. 3 times 6 is 18. 4 times 9 is 36. This reduces to 1/2. When you divide, you are going to keep, change, flip. So when you divide fractions, keep, change, flip. So that means we keep the first fraction, we change the division to multiplication, and we flip the second fraction. So 8/3. And then we just multiply across. 5 times 8 is 40, 6 times 3 is 18, and this is going to reduce to 20/9. All right, so let's get to the point. Multiplying rationals. So we have x squared over x plus 2 multiplied by x squared minus 5x minus 14 over x squared plus 2x. So I'm going to give you some basic steps that we're going to follow, right? So here they are. I'm just going to write them. I'm just going to put them there so you can just see them. So we're going to begin by factoring everything that can be factored. So this we could factor. And this we could factor. This here, I'm going to do that in a different color. This cannot be factored. Cannot be factored. So you just leave it. All right? You're just going to leave that like that. All right, so let's get to it. So factor everything that can be factored. So we're going to get x squared over x plus 2. And you know, the x squared, I just left it there. I'm going to do something with that x squared later. Multiplied. So I got to factor this here. So that's going to be 2 bubbles or 2 sets of parentheses. So I'm going to write my 2 sets of parentheses. And I'm going to factor this. So that's going to be x and x. And I need 2 numbers that multiply to negative 14 but add up to negative 5. So that's going to be 7 and 2. And I know this has to be negative. This has to be positive. This is going to factor this, I need 1 set of parentheses, 1 bubble. And on the outside, I'm going to have x. And then it's going to be x times x gives me x squared. And then x times 2 gives me 2x. So that was step 1. All that work right there was step 1. Okay, step 2, cancel out. So now it's time to cancel out stuff. So I could cancel out this x plus 2 with one of these x plus 2s. I could only do it with one. So I'm going to go ahead and I'm going to pick this one. So I canceled this x plus 2 with this x plus 2. Now, I can also cancel out this x with one of these x's. So that is going to go. Because remember, right, this is x times x, and one of those x's is going to cancel out with this x. And now I could multiply across. So I just finished step 2. I canceled out everything that could be canceled out. So now I'm up to the next step. Step 3, multiply across. So I'm going to have, let me use a different color for this, x times x minus 7. So I'm just going to write it first. X times x minus 7. And the only thing that's left here is just like an invisible 1. So I got x plus 2 times 1. So I could just write x plus 2. Now, in case you're wondering, can you cancel out this x with this x? The answer is no, you can't, because technically this is a binomial, right? This is one term. So you can't cancel out that x with that x. And this is your final answer. There's nothing else to reduce here, so you are pretty much done. And you know, the multiply across step, all that really means is, you know, just whatever is left on the numerator, put it together, and whatever is left on the denominator, put it together. You don't have to actually distribute this, you know, to get something. You can leave it like that. So this is your final answer. All right, let's try another one. Dividing rationals. All right, so before we do anything with division, so before you start factoring, you have acknowledge that you have a division problem here. We need to do the keep, change, flip thing. So we're going to rewrite this like this. Sorry about that. So keep the first fraction, change the division to multiplication, and then you flip. So this got flipped, all right? This is not the same thing as that. So this gets flipped. That's the keep, change, flip. Now you're going to factor everything that can be factored. So this could be factored. So we're going to factor this. This could also be factored. This cannot be factored. All right, so this cannot be factored. Cannot be factored. And same thing with the bottom one. This cannot be factored also. All right, so let me just erase some of this stuff so that it's not cluttered. So let's get to it then. Boom, boom, and multiplication. All right, so to factor this, I need 2 sets of parentheses. So that's going to be x and x. I need 2 numbers and multiply to 28 and add up to 11. So that's going to be 7 and 4, and they'll both be positive. 7 times 4 is 28. 7 plus 4 is 11. Now I have to factor the bottom here. That's also 2 sets of parentheses. And that's a difference of perfect squares. So that's x, x, and I can do plus 4 minus 4. Now remember, this can't be factored, so I can just write that. And this cannot be factored either, so I'm just going to rewrite it. And you know, technically, this has a set of parentheses around it, just so you know. So after factoring everything, cancel out only top with bottom. And it says only bottom with top or top with bottom. So what that means is I could cancel out this x plus 7 with this x plus 7. And I could also cancel out this x plus 4 with this x plus 4. So what am I left with? I'm left with x minus 7 over x minus 4. That's my final answer. All right? Okay, I hope this video helps. Take care.